Hello, good afternoon, everyone, and welcome back to the Future of Construction. We're joined here today by our fearless facilitator over the last week, Kellyanne Mahoney from Autodesk, and special guest, Brian Scott, who's an architect from Elkus Manfredi. So he's going to be talking a little bit about what it's like to be an architect, the skills you need, maybe what you're interested in, and if you're interested in these things, maybe you should be an architect. As well as answer any questions that you all might have around the work of an architect, as well as the projects that you're working on. So Brian, I'll hand it off to you. Let us know a little bit more about yourself and the work you do.
Okay. Hi, everybody. So thanks for joining us. I'm an architect in Boston. I've been an architect for about 40 years. I started, I grew up in Cincinnati. And then when I was 17, I went to college down in Houston, Texas. From there, I did my internship in Sydney, Australia. And then from there, moved back to Dallas. And then from Dallas, moved to Boston. And I've been here now longer than I've been anywhere. So Boston is my home. And I've had the privilege of working on a lot of projects and buildings, some of which you may recognize, most of which you won't. So we probably won't, do a survey of all the projects that I've worked on. But to give you a little bit of insight into me and how I became an architect, it starts with in third grade, sort of recognizing. I remember sitting by the shore and realizing that I could feel time passing. And I felt, I was acutely aware that every second that went by was a second gone. I would never get it back again. I couldn't relive it again. And that it just continued on at a pace that I really had no control over, but I could definitely experience it. And it only went in one direction. I couldn't go backward, I could only go forward. But it was that curiosity I had about how things were and why things were the way they are, I think, that led me to want to ultimately do what I'm doing today. So in addition to time, there was, so I've always been a swimmer. I've liked the water, and I've always been around water, and so the idea of moving forward in time, almost kind of swimming through it, was very much part of who I am. And so a little bit later on, I started building furniture. I did some drawing. I had a couple of friends in school that we used to do a lot of map making, and I liked exploring. I liked the outdoors, hiking and camping. And so by the time I got out of high school, and I was thinking about what it was I wanted to do, I realized that pretty much everywhere on the planet, people had built buildings. They built their homes, they built their offices, they built, their stadiums, their places to play soccer and football. And as I thought about that, I thought, you know what? If I were an architect, I'd always have a job because there's always building to be done. And that's what got me sort of interested in it and moving in that direction. And in addition to the time and the science questions, how this all fits into STEM, I did an experiment in my science class, my senior year, that involved radioactive carbon isotope and how and whether I could use radioactive carbon dioxide in plants to see where the plants stored carbon dioxide. And so, with that science background and science in mind, I went to college to be a physicist. And I was going to be a research physicist. And then early in my freshman year at college, I started hanging out more and more in the architecture lab. And I made a friend there from Puerto Rico named Arturo Rodriguez Garcias III. And he was working on projects. I started helping him with his projects, and I got hooked. And the next year, I took all architecture courses, no more physics courses. But I realized that architecture, if you ask the question, well, which part of STEM is architecture involved in? Is it involved in the science or the technology or the engineering or the math? And the answer is all of the above, because an architect has to collaborate with a big team of people, using math, using and applying engineering, using technology and designing technology into our buildings. And all of that, of course, falls under science. We design out of the imagination, but at the end of the day, the buildings we build have to keep the water out. They have to perform well. They can't fall down. They can't fall down in an earthquake. They have to be very carefully designed for public safety in terms of fire and getting people out of the building, and the building not burning up before everybody can get out. So there are all the life safety aspects of that. And all of that involves all four of those components: science, technology, engineering, and math. I don't know if you can see my screen, but this is actually a Google Earth view of Roxbury. And just before this call, we started talking about one of the buildings that I worked on fairly recently. I don't know if you can see the hand moving here around this building, 65 Allerton Street. This is the headquarters of Suffolk Construction. And if we were to come down here to the street view on Magazine Street, I think we might be able to see the new building that we designed recently, Elkus Manfredi, for Suffolk Construction, their headquarters. I don't know, some of you may be familiar with Clifford Playground, which is the ball field that we're looking at right here. And this is the Suffolk Construction headquarters, their new headquarters building behind. So with that as an introduction, I want to take us through an exercise to get you guys using your imaginations. I'm going to close, or I'm going to minimize Google Earth here. And this was a rendering of the building that you just saw long before it was built, just the art. I'm going to close that as well. And we'll minimize that. And while it's up here, we'll just take a quick shot of this dramatization, a little movie of the interior of Suffolk. They have a stadium where they have their staff meetings, and they train their construction staff and their administrative staff. We built this stadium that faces out over Clifford Park for them to be able to have those meetings. And this is a little video image of what that was going to look like as we were designing it. So I'm going to close this now. And so here on the screen, this is what we do. This is what architects do. This bottom image here is the ground floor plan of a townhome building. This happens to be a townhome building in Australia, where I did my internship. Here's the second floor plan, and here's a section. A section is a vertical cut through the building that shows the insides of the building. So we've cut the building in half, and we can see the other half that's inside here. So this table and chairs here is this table and chairs here on the ground floor. This stair going up is this stair going up here. So we have plan, section. And then the trick here is see if you can imagine in your mind, from looking at the plan, the section, what you think a whole group of these buildings spread on a hillside might look like. And I'll give you about 5 seconds to do that. 1, 2, 3, 4, 5. And then we get a picture of what that actually looks like. So architecture is about conceiving of things, documenting them in a very specific way. That means drawing them, plans, sections, and elevations, and then communicating that to a contractor so that they can build it. And this has been the time-honored way of doing buildings and construction, is you plan them, and then you communicate the plan, and then you execute the plan, you build it. We'll take you through a couple more of these, and then we'll open it up for questions. So here we have a plan. So here's a group of buildings. This building here is blown up here, and we see a floor plan of this. This is an office building in Australia. Here's a section through that office building, so we can see the insides. We're not looking at the outside skin of the building. We're looking at it cut. So we're cut through the floor plates here, and we're cut through this sun shading on the windows on the exterior. And you can see where we've got some trees and things growing on cut-ins in the building at the upper levels. That's the section. This is an elevation, so now we are looking at the outside skin of the building. And now imagine what this might look in 3 dimensions. I'm not going to show you a picture of the building, but I'm going to show you a picture of a model of the building that we built before the building was built. Okay? So it's just, I know we can't talk back and forth here. But I'm interested to know, if you guys are matching up in your mind with what you're seeing in the photos here. This one's going to be a little more difficult. This is what's called a reflected ceiling plan. So we're lying on our backs and we're looking up at the ceiling of a floor here. And this is actually the concrete structure. These 4 swoopy things at the corners here are actually columns. You usually think of a column as being round or square. Well, the columns on this building, and this is another office building, this is in Hong Kong. These are all swoopy and have some nice shapes here. All these shapes are very carefully thought out for structure and for lighting the inside of the office space. And you can see the big deal here is there are no columns inside the office space. It's just what's called clear span construction. This is a drawing of one of the beams that supports the exterior wall of the building. And this is a half of the beam, and it's shaped in a very particular way so that it can be structural and the outside skin of the building and sun shading for the windows of the building. And that's the outside of the building. I don't know if that's what you had in mind or not, but those pieces that we looked at are what produce this 3-dimensional result.
Ryan, you have a question from one of Peter's students, or Mr. Kovach's students, sorry. And he asked, how often are your ideas futuristic in the sense that the technology is not yet available to build the idea?
Oh, that's a great question. Well, at this stage in my career, I'm not doing much experimental stuff. We have to be very practical and very responsible to our clients' budgets. And so we are using primarily existing technologies when we design buildings to be built. Cast in place concrete, steel, structural steel. The things that are readily available tend to be less expensive. And so in that regard, our work doesn't involve much futuristic experimentation. I'm very interested in some of the things I've seen, though. Like the most outrageous one was mechanical spiders that actually spun carbon nanotube structure out on the site, completely automated and without any human intervention except for the programming of the robot spiders. So I don't know if that answers your question, but it's stuff we think about is really in the realm of fantasy. Okay.
Yeah, Brian, got a question for you too. Since you've been in the business of architecture for so long, and the students are working on a project related to thinking about environmental justice in buildings that utilize, green infrastructure and sustainable technologies and techniques, how have you seen the field of architecture evolve in your experience over these years in that way to become, more sustainable and thinking more green about, the buildings and the impact?
So that's a great question. And I think generally we are slow to adopt. We're slow to change as a profession. We have goals of sustainability and efficiency that we are already behind where we need to be in order to achieve those goals. I think we're becoming much more aware about energy use and trying to make more efficient building envelopes, make efficient use of materials. But what we need is more robust accountability for the fact that every new thing we create, if you think about a building, a glass office tower, you build that, but you have to mine the silica. And so everything we create is causing destruction somewhere else. And I don't think we've fully accounted for that. That's the big problem. And I think the only solution that makes sense from a physics standpoint is we got to build less, and we've got to consume less, and a lot of things that this is a running freight train, and nobody wants to jump off because they're afraid they'll be left out of the economics.
Well, it's a good thing we have a group of students. A group of students are future architects, engineers, and constructioneers to help us solve this issue for sure. So wondering sort of, you talked about your varied experience. It didn't seem like you had any idea, even though you had your revelations at a young age about what you actually wanted to do growing up. So can you talk about, looking back, what are the skills, the classes, the experiences that really got you on track to be an architect and you feel like are really essential to becoming a successful architect?
Can I also add on to that question? Because I was thinking the same. In looking at one of your sketches, it looked like it was hand drawn. And I was wondering also, could you speak to the skill of actually drawing things by hand and how important that is to become an architect, or is that a potential pathway for students into?
It's essential to be able to communicate your ideas. However you do that, I think architects traditionally have had a good hand, and the architectural profession still has a tremendous amount of respect for those of us who can draw. So the architectural brain, the architect's brain is a little bit different on average than other people's brains. A lot of times we think, oh, however it is we think, well, everybody must think that way, but we're all different. I'm a very visual person, very spatial person. And as I think in 3 dimensions, I think in color. I can move and manipulate things in 3D space in my mind, and I've always been able to do that. And it took me a long time to realize that not everybody could. We work with a lot of clients who cannot read our plans and our drawings and need a three-dimensional model. So the technology and the tools that we have now to do that are excellent, but being able to sketch is part of the communication equation, and being able to do that well, to communicate your ideas, is essential to being an architect.
So you hear that, kids? If you're a doodler, maybe there's a future for you in architecture and using those skills to communicate your ideas. It's great. So we're coming near the end of our STEM chat today, so we can have maybe a couple more questions. But I was also just wondering, we have students who are middle school age, and you're going to have a combination of kids who, might be very interested in a STEM field or architecture, or might be kind of turned off by the idea due to their past experiences or just some, ideas they might have about STEM that might not just be true. I was wondering if you could give advice to sort of those sets of students if they are interested in getting into STEM or architecture in particular, what you would suggest to them at a young age now to be thinking about in their future path forward.
Pursue your passion. Be passionate about something and pursue it. And you can do, with that, you can do pretty much anything you want. With architecture specifically, I can tell you, when I was your age in 7th grade, Jim Sider and I we were drawing a lot of maps. We loved maps. We loved looking at the globe. We liked thinking about geography. I loved looking at the stars in the night sky and putting a telescope on things. Those are, whatever your curiosity is, don't let anybody else put it down, make you think it's not cool. Just be your own person. You're all curious about something. And if you dig in and just follow that curiosity, you'll get where you're supposed to be. People are like water. We find our own level if we're left unencumbered and free to do that.
Great. Well, thank you, Brian, for the inspiring words and for joining us here today. Students, if you have any more questions, let us know. You can just ask through your teacher and we'll communicate them to Brian and get you your answers. Again, thanks so much, Brian. We really appreciate you having here today and walking us through the day in the life of an architect and how awesome it is. Thank you.
You're welcome. I should mention that all this behind me is my firm, the other 284 architects that I work with.
And kids, maybe one day you could be up there as well.
Give me a call.
Thanks, Brian. Have a good one.
Thank you, Brian.
Bye, Kelly.